our lesson today, we're going to be learning the third method for solving a quadratic. We've done graphing, we've done square roots. This is the third method. It's called completing the square. Before I show you what this method involves, let's do this review problem here where we're asked to simplify x plus 4 squared. Remember, when you square something, you multiply it by itself. So you have to write x plus 4 twice and then FOIL this thing. So I'm going to distribute the x, and I would get x squared plus 4x, and then distribute the 4, and I'd get 4x plus 16. We would combine the x's, and I would get x squared plus 8x plus 16. Okay, why does this matter? Well, think about at the very end of last lesson when we were using square roots to solve a quadratic. I showed you an example kind of like this, and we looked at why you could not use square roots to solve this kind of quadratic. And the reason was because that there was this b value, or there were x's in the middle. So we're going to call that like the bx term. When that bx term is there, square roots doesn't work. Okay, so obviously we need a third method here because square roots doesn't work all the time. Graphing's not very accurate, so here's where this completing the square comes in. So say that I do want to solve this quadratic. The methods that I know so far aren't going to help me. So let's look at the left-hand side, this x squared plus 8x plus 16, which is exactly what I got right here when I simplified this guy. So this quadratic is the same thing as this right here. It's just a more simplified version. So here's what I'm going to do. I could rewrite this quadratic trinomial, x squared plus 8x plus 16, as this, x plus 4 squared, because technically those are the same thing. Because I can rewrite this trinomial as this binomial squared, this is called a perfect square trinomial because it can be rewritten as a binomial squared. Perfect square means like something times itself equals this, like 6 times 6, 36. 36 is a perfect square. So this guy is called a perfect square because there's some binomial that I can multiply by itself to get this thing. Okay, moral of the story, being able to rewrite it like this is going to help me solve the quadratic for x. So what I'm going to do is I'm going to take the quadratic that I'm trying to solve right here, and instead of on the left-hand side having this trinomial, I'm going to put the binomial squared. Set that equal to 0. If I'm looking at a quadratic like this, I actually can now use square roots to solve. So here's how I do that. Before I can break up what's in parentheses, I want to undo squared, which I know square root will do that. Square root the 0 as well to keep it balanced. Do the same thing on both sides. And then I just have x plus 4, square root 0 is just 0, equals 0. Now this is super easy to solve for x. Just subtract 4, and there's one solution. It's x equals negative 4. Yay! Okay, let me show you how this works in another example. So here's what I'm going to do first on this one. And we'll get into the details in a second here. But the first thing I want to do to this quadratic trinomial, and I'm just trying to solve for x, I want to factor this thing. So if you forget how to factor, that's when you break the trinomial into two binomials. To do that, you're looking for, and this one's just going to be x and x, you're looking for two numbers that multiply to be 9 and add to be 6. It's 3, if you can't see it. 3 times 3 is 9, 3 plus 3 is 6. 3 and 3, so I can rewrite this guy as x plus 3 times x plus 3. Now use this idea up here. If I have something times itself, another way to rewrite that is x plus 3 squared, which is exactly what I want because now I can use square roots just like I did up here. So it'd be x plus 3 squared equals 36. Now I'm going to do what I just did and square root both sides. And I would just have x plus 3 equals, be careful on the right hand side. It didn't happen on this last example because it was 0. And the square root of 0 is just 0, not positive or negative, just 0. But remember last lesson we said every time you take the square root, you have to write this little plus minus symbol to account for both solutions. There are two solutions on this one. Okay, remember the square root of 36. 6 times 6 is 36, and negative 6 times negative 6 is 36. So there's two answers for the square root of 36. You've got to put that symbol. Okay, two solutions. So what I want to do is I want to write two equations now to find them. So I know that x plus 3 can equal 6, and x plus 3 can equal negative 6. If you forgot the plus minus sign here, you would just get one answer and you'd probably be really stuck on where the other one came from. So don't forget that little symbol. It makes a big difference. Write two equations from that, and then I just subtract 3 on both sides in both equations to get my answer. So subtract 3 here, and one answer would be 3. When I subtract 3 over here, I would get negative 9. Guys, the good thing about the solving stuff in this unit is that you could check your answers if you honestly were unsure of yourself and had the time. So all I'm saying is that I should be able to plug in 3 for x, and it should equal 36. So why couldn't I check that if I wasn't sure? And it does. I could do the same thing and plug in negative 9, and that equals 36 too. So totally can check your answers here. All right, I'm being bold. I want to see if you guys can do number 2. So this is a perfect square trinomial. This guy was 2, meaning it factored into two binomials that were the same thing. So you can rewrite it as this binomial squared. This guy is the same situation. So when you factor this, x and x, you should come up with the same number that plugs in here and here. So then you can rewrite this as just x plus or minus something squared equals 9. And then you'd follow along with the steps I did here. So see if you can do this one, and I'll check it next time. Like I just said, these two examples, the quadratic was a perfect square trinomial. Okay, if it's not a perfect square trinomial, which obviously we're going to see that it always gets a little bit more challenging than what we start out with. If it's not a perfect square trinomial, we're going to make it one. And to do that, we're going to complete the square. Hence what the name of the notes are called, completing the square. Okay, I know this is not a perfect square trinomial because there is no single number that I can multiply it by itself to get 13 and I can add it to itself to get 12. Doesn't exist. So I want to make this a perfect square trinomial. The first thing I want to do is I want to get the 13 out of there. And it's a negative 13. So whatever the c value is, so it's the c value. In this case, it's negative 13. You want to get that out of there and move it to the other side. So to do that, I would add 13. So now it would be x squared plus 12x. I'm going to leave a blank right here because I want to make this a perfect square trinomial. And now it equals 13, not 0, because we moved the 13 to the other side. Now I need to figure out what number can I put right here that makes this quadratic a perfect square. Okay, here's how I figure this out. I need to think about which number adds with itself to get the middle term, the b value, which in this case is 12. So what number added to itself gets me 12? Well, 6 does. Now, it has to be the same number because we're trying to make a perfect square. So can't have different numbers involved. It's got to be the same thing. Once you find what number adds to itself to get 12, then you have to square the number to get what goes here. Because I know from what I did here, guys, the number has to add to itself to get like 6 on this example, and it had to multiply to itself to get 9. So once I find the number that adds to itself to get the middle term, I can either multiply it by itself, or a simpler way would just to be square the number. So I know 6 plus 6 is 12, so then I'm going to do 6 times 6, or 6 squared, which would be 36. That's the number that goes on the line here. Okay, let's continue this over on the other side. Okay, ran out of space there. It's kind of a lengthy process, as you can see. So I know that I want to add 36 in this slot right here. Now realize that in math, you can't just add something to one side of the equal sign. You have to keep things balanced. So whatever I choose to add to the left-hand side to complete the square, I have to add that over here on the right-hand side as well. So now I'm looking at this, which is looking a little crazy. This is now a perfect square. I can factor this into x plus 6 and x plus 6. And once you found the number that you squared to come up with 36, you can kind of save yourself a step. This trinomial can be rewritten as x plus 6 squared, which is exactly what I want to be able to do, so I can just square root and solve. Be careful on this side. You got to do 13 plus 36. That'd be 49. Now I can take the square root, and I would have x plus 6 equals plus or minus 7. 7 times 7 is 49. Negative 7 times negative 7 is 49. Don't forget that symbol. Then, like I said, you write two equations to solve this for x. Okay, so x plus 6 can equal 7. X plus 6 can equal negative 7. And this kind of breaks it down really nicely, guys. So you want to take good notes, and you want to keep these notes next to you when you're first practicing, because this stuff takes practice. This is like seriously a lengthy process. But these notes are breaking it down real nicely, so if you get stuck, you can follow along with this example and see where you got stuck. Once I have the two equations, I just solve both of them. So over here, I just subtract 6 and get 1, subtract 6, and I'd get negative 13. So those are the two numbers that you can plug in. Where'd I even start? Right here, and it should equal 0. Woo! This is fun, huh? All right, like I said, it just takes practice. It's the same thing every time, so the more you practice it, the more you'll have the process down. Let me show you how I'd start. And I already know I'm going to need to draw lines here so I don't get my work all mixed up. Already going to tell you, you guys are going to do 2, I'm going to do 1 and 3. Okay, so follow along. If you are not looking at a perfect square trinomial, and they're telling me, hey, use completing the square. So I'd want to assess first, is this a perfect square? So can I factor this? Is there some number that multiplies times itself to be 45 and adds to itself to be 18? No, there's not. And guys, if this C value isn't a perfect square number, you know right away this is not a perfect square trinomial. So your first step is to get the 45 out of there. Move the C value, subtract it to the other side. Now I'm looking at x squared plus 18x, and then I'm going to leave a space because I want to complete the square right here. And I'm going to put a space over here too. See, I'm already running out of room. I should have scooched this over. I need to complete the square right here. So we'll address this right side in a minute, but I need to figure out what number should I put here that makes this a perfect square trinomial. So I know that the number should add to itself to be 18. Or in other words, save yourself a step. Yeah, you can think what adds to itself to 18, but you could also just divide 18 by 2. And that works every time. So that would just be 9. 9 plus 9 is 18. So to come up with what number completes the square, you just square 9. And that would be 81. Do not forget, whatever you add on one side, you got to come over here and add it to the other side too, to keep your equation balanced. So here's what I'm going to do on the left-hand side. My goal is to write this quadratic as some binomial squared. Well, once I come up with the number that I used to get 81, that's the number I put in my little set of parentheses here. This quadratic is the same thing as x plus 9 times x plus 9 when it's factored down. So I'm going to put it as x plus 9 squared. I got to do negative 45 plus 81 over here, which would be 36. Now it's so much easier. I can just square root both sides. And I would have x plus 9 equals plus or minus, don't forget, 6. There's two answers, so I'm going to write two equations. And then I solve both of these, and one answer would be negative 3, and one would be negative 15. Keep in mind that you could check these. You could plug these numbers in one at a time into the problem for x, and it should equal 0. I'm not going to take your time showing you how to do that, so just trust me, these are correct. I want you to try 2, maybe watch me do 3 here real quick first before you go back and brave 1 on your own. So number 3, if 104 is not a perfect square, then you got to get it out of there. I'm going to subtract it over. And I know I'm going to want to complete the square, so I'm going to leave a blank. And write the blank on both sides because you got to add that number in both places. Okay, my goal is to write this side as something squared. So what goes here to make this a perfect square? Well, what I said was you could just take this b value and divide it by 2. And that would be 10. So 10 plus 10 is 20. This number should be 10 times 10. Or you could just square 10. Either way you want to think about it. You want to add 100 to both sides to keep this thing balanced. Okay, now I can rewrite this left-hand side, this quadratic trinomial, as x plus 10 squared. And over here on the right, negative 104 plus 100 would just be negative 4. Okay, now I can square root both sides. And I would have x plus 10 equals, okay, wait, think about this. There is no number that when you multiply it by itself, you get a negative. If you put this guy in your calculator, and we saw this last lesson, you get an error. Okay, if this happens, you just stop right there. This is actually an easier problem because of this. There's no solutions. Okay, you cannot take the square root of a negative number, so if this ever happens while you're solving using any of the methods that we see, stop right there and write no solution. Nothing I can plug in for x that's going to actually make this equal 0. Okay, so we got some tips down here at the bottom, people. Things to remember. You want to have these notes handy when you start practicing this on your own. So first tip. Take the time to get the correct number that completes the square. It's like how I got 81 and 81. Take your time getting that number. If you mess that number up, you will never be able to get the correct answer. Okay, so be careful there. Second tip, do not forget. This is probably the number one thing people forget. Don't forget the plus or minus symbol every time you take the square root of a number. Okay, it will make you forget about one of the solutions. So you can only get the problem half right. Third tip is make sure that you write your two equations when you're going to your last final step for solving for x. Okay, that's completing the square.